Radio TV phono nut, and we have a Hoffman solar-powered AM transistor radio, likely from the late 1950s. Now this set can be powered by either this top-mounted solar cell or an internal battery pack. The radio is dead in its present state. I have not opened the back cover, so we will do that shortly, and then we'll all find out together what kind of condition this is in. So looking at the back, I see 3 newer Phillips head screws as well as one older looking flathead screw. I suspect the flathead is probably the original, so we'll need two screwdrivers here to get the back off, so we will do that right now, and then we'll find out what we've got to work with here. Hoffman Electronics Corporation, Los Angeles, California. Alright, let's see what we got. Okay, the battery is missing, and I think this originally used a 4.5 volt mercury battery. The circuit board on the foil side does not look like it's been tampered with, so that's a good sign. And here's our label, Hoffman Electronics Consumer Products Division. General operating characteristics. Yeah, this is basically just a parts layout and that sort of thing. And this is not a conventional pull-off knob. You have to unscrew this silver thingy in the center, and then the knob lifts off. And then a little plug comes out of this decorative plate, and then we have to lift that off and then remove this screw right here. And this dial is metal. It's not some cheapo plastic thing, so this wasn't some cheapo made in Hong Kong radio. This was an American-made set, and Hoffman stuff, based on my experience, was generally high-end stuff. Now this solar cell is dated, looks like October the 10th of 1958, so it's probably about when the radio was made. Now some screws that I erroneously removed whenever I was taking this apart were these 2 screws and these 2 screws. These 2 screws hold the tuning condenser in place, only I didn't know that at the time. And these 2 screws hold the speaker in place, which that will probably have to be moved out of the way for troubleshooting. So basically all you have to do to remove the chassis, there's one screw on the battery holder, and then you have to unscrew the retainer that holds the tuning knob on, and then remove this dial plate if it doesn't fall off, and then there'll be a screw recessed on the tuning capacitor that you remove, and then the whole thing just slides out except for the solar cell. Here's the chassis, all primitive solid state technology here, open air variable capacitor, which is nice. Old school capacitors, old school germanium transistors down in there. I'm sure these capacitors are dried out by now. And this solar cell just unplugs from the board, negative here, positive here. Alright, I'm out in the sun checking the solar cell. We only have an output of about 1.6 volts. It should be better than that, so that could explain one reason why the radio is dead. Thanks to the Radio Museum site, we have a schematic for the radio, and according to the Radio Museum, this cost $75 whenever it was introduced in 1958, which was quite a sum of money back then for just a little AM portable radio. So we have our 2N252 converter transistor, 2N253 first IF, 2N254 second IF, and then we have our detector diode, followed by a 2N238 driver, and then we have our push-pull output stage, which consists of a 2N 185 and another 2N 185. And then down here we have our battery, which is, like I said, a 4.5 volt. Well, they have it listed as 4 volt, but I think it's technically a 4.5 volt mercury battery, which has long since been obsolete, and I doubt there's a modern day equivalent for it. But there's our switch to switch in either the built-in battery or the solar cell. So of course we'll have to come up with some voltage from another source, since our solar cell appears to be pretty weak. Alright, we have our 4.5 volts crudely created from 3 brand new AA batteries, and we have our milliamp meter placed in series with the positive battery lead. So let's turn it on and see how much current we draw. The schematic says about 7.5 milliamps. And we're drawing, we started out at over 100 milliamps, and we're dropping down to probably capacitors reforming. But it is dropping down. And I am hearing some static from the speaker. Alright, where is our tuning condenser? Alright, I'm getting a little bit of a station here, but not nearly as good as it should be. And the current is dropping down, slowly but surely. Now, actually, I think that weak station I was on was 670, so if that's the case, this is doing pretty good. This is on a local station.
Dedicated to encouraging those who have lost hope. The ministry seeks to serve those who cannot find peace and are considered unfit.
Alright, at minimum volume, we're drawing 32 milliamps.
Testimonies of lives that have
Maximum volume, we're drawing about 41, 42 milliamps. Well, the radio actually seems to be working on all original components. That's amazing. And our current draw is slowly dropping. I'm sure that 7.5 milliamp rating listed on the schematic is at minimum volume and no signal. Now we're down to 23 milliamps at minimum volume. Now, as far as capacitors, it could be leaky and causing excessive current draw. As you can see, that plainly says 7.6 mA draw here. I would be looking at anything, a capacitor with one end connected to B plus and the other end connected to ground, such as this guy right here, 150 microfarad, one end connected to B plus down here, and then the other end connected to ground. And we'll see if there's any others. Now, I think that may be about it. That would be my number one suspect, but if I can get this thing to behave, I would like to keep it original. You know, these older transistor radios, if they work, I really don't like to mess with them too much, because the components are actually part of the history, and unlike a tube radio, the components in a transistor radio are more easily seen if you remove the back cover, although in this case the parts are concealed within the cabinet, so I don't guess it would be much of a big deal. But I really don't want to mess with this if we can keep it working okay. Now, another thing that could cause excessive current draw might be if one of these output transistors was leaky. And with old germanium transistors of this age, that could be highly possible too, but so far the output doesn't sound distorted or anything like that, so I'm leaning more towards this capacitor. And we also have another bypass capacitor on the other end of this 100 ohm resistor. That could also be at fault. Now some other capacitors in this radio. Let's see here. Coming off the detector diode and the top end of the volume control, we go down through this 3.3 k ohm resistor, and then we run down here, up and away we go up here to this capacitor. That looks like our AVC filter, and if that one dries out and opens up, the radio will just oscillate and squeal and misbehave all over the place. And the same thing could happen if either one of these bypass caps on the B plus line were to open up. And then we have another electrolytic up here on our driver stage. It's a emitter bypass cap. If that one were to open up, you could lose some audio, some volume level, as well as possibly have some oscillation. And then we have this 10 microfarad volume control coupling capacitor, which is a common fault in transistor radios. If it dries out and opens, you'll just get little to no audio, and I think that's about all the electrolytics I see in here. Alright, now let's turn it on and see where we are from a cold start with the current draw. 20 ton, 22 mils. If you recall, when we turned it on before from a cold start from this radio, probably not seeing the light of day in decades, it went way up there to like over 100 milliamps. Now, what I'm leaning towards doing with this at this point is just leaving it original. As far as the solar cell, I could come up with something modern to put in its place, but it would look obviously modified. I really don't want that. I believe these old solar cells are made out of selenium, and they do get weak over time. So I think what we're going to do is put it back together, and if these AA batteries can be made to fit in this battery compartment, then we'll rig those up some sort of way, and then we'll at least have a way to power the radio. Just for fun, here's one of the bypass caps, 150 microfarad, reading 250, and that's usually indicative of a leaky capacitor. Well, this is one of those situations where I should have left well enough alone. I changed that capacitor. Now it's totally dead and has essentially no current draw. You know, like 0.07 milliamps, which ain't enough to amount to anything. So what happened? Alright, I'm connected direct, checking voltage. 4.8 volts with the radio not turned on, and 4.75 with the radio on, so not really drawing much of anything there. I suspect our problem is in our audio output stage. Well, now I turned it on and it started to work again, so obviously we have a bad solder connection somewhere.
I think the painting part of it is definitely. At the NFL Combine, my wife and I were in Indianapolis for completely separate reasons when we did the first coverage.
Okay, we've got a bad solder connection somewhere, I do believe. Well, now it's playing direct, but whenever I go through my amp meter here, I get nothing. Now what it could be, these crappy clip leads, because they generally do not solder these. They're usually crimped on, and more than once I've had these clip leads with a faulty connection. Cheap Chinese crap. Okay, well my meter seems to be jacked up. I have to open it and see if I blew a fuse. I had to move it over to the amp range instead of the milliamp range, and I'm drawing about 21 milliamps now. which is slightly lower than what we were after we replaced that leaky capacitor. Right now we've dropped down to 18 milliamps, so we're getting down to the desired level. I want to try to get this current draw as low as possible to ensure that our battery lasts for a longer lifespan. Yeah, all these caps are likely very leaky. This is a 10 microfarad. I think this is the volume control coupling cap, and it's reading 61 microfarad. So that's like I said, when they read like that, that's usually indicative of a leaky capacitor.
The situation.
All right, all of the caps are replaced.
You know, when you're growing up,
and we're drawing
point your heroes, the
0.06 amps.
I grew up in that
maybe not.
window between.
I'm on the wrong thing. I'm on the capacity scale. Let's try putting this on the right scale.
I always loved Brian Blade.
All right, we're still drawing about 19-20 milliamps. Let me turn this volume down.
All right, well, let's go to
down, not up, silly. All right, drawing about 20. So that's really probably about as good as it's going to get.
Number 89. Love Brian Blade. And the other part, first of all, I love Camino.
So I'm about ready to put this thing back together and call it a day. Did I show you this at the beginning? This has the Union Made sticker. I think I remember seeing those labels in some Crosley and Sonora radios. And now we can add Hoffman to the list. Alright, there's 670 barely coming in. Not too bad for what this is. Alright, this is about as jake-legged as it gets. I had to go with 3 AAA batteries so they would fit in here. And we have them soldered in series to get 4.5 volts. Now, even me sanding these battery contacts, it was still hard to solder our battery leads to those contacts. So that's strictly going to be somewhat temporary until I can come up with a more feasible solution. But right now the radio does work. I hope it still works. Yeah, it still works. So let's get the back cover on it and see what we can pick up on it. Alright, here we are back together, and WSM is going to fade just as I'm turning the camera on. I've got to find the little plug that goes over this dial. I goofed and I dropped it outside, and I've got to get out there in the daylight and find it.
I was in here an hour and a half earlier than no se salva en este caso all the way in. I'm going to stop at a stoplight at my phone. Right in the world's going.
Yeah, this is cool. The British and then yeah.
The over-coverage of Taylor Swift has been a ridiculous topic the last few days. But you want to get ridiculous. You want to get really ridiculous. You want to get...
I'll be honest with you, several years ago, when I first heard about Taylor Swift, I thought she was a man. Just like my dad, who wasn't really big into country music, he always thought Merle Haggard was a woman. Until he moved into this house, and the lady that lived next door was a Merle Haggard freak. And that's when he found out that Merle Haggard was a man.
I have to give the union credit here. Who cares too much Taylor Swift coverage by saying...
The way they were on picture, and the golden light is upon me. He loved...
The political problems, right? My God.
But yeah, it's working pretty good considering what it is. So tomorrow I'll get out and try to find the plug that goes in this dial thing here, and But as far as it being a solar-powered radio, I think its days of being solar-powered are over with, because I really don't want to hack up this solar cell to try to put something more modern in here. I'd rather keep the original look, but at least we can run it off of a battery. And this is not going to be in regular use, so that alkaline AAA battery pack I hacked together should last a fairly long time. You know, just out of curiosity, I was trying to figure out who made those capacitors. They have an EIA code of 911, and according to this, that is International Electronics Industries Incorporated out of Nashville, Tennessee. I don't think I've ever heard of those, that brand. I wonder if that eventually turned into Nashville Electronics. I remember seeing some electrolytic capacitors from the probably the late 50s into the early 70s that were branded Nashville, and of course they were all garbage too. Most of those you just replace on site, along with the ones that are marked Whale and Callens and such names as that. Those in the hard plastic black case, you usually don't even bother to check those. If you see them, you replace them.
Wasn't so bad. What do you think it's going to do for the Republican Party and chances of holding on to leadership in the majority when it looks like you're the ringleader of a circus led by Matt Gaetz, who likes to blow things up?
All right, I found the little plug that I dropped. The radio is back together again, just like we found it, and working just fine except for the solar cell. Now, as far as the battery, shut up a minute, just turn it off. As far as the battery, what I think I'm going to do to make this more, make this neater looking and make it easier to replace, I'm going to get a dual AAA holder and then a single AAA holder, and then attach the two back to back, and then wire them in series to get my 4.5 volts, and then I can wire that permanently into the radio. And when the batteries need to be changed, they can easily be done so without having to mock up another battery using AAA batteries and soldering them together and all that good stuff. So I guess that's about all we got for this radio.